Today's lesson is on repeating decimals and how to actually make a repeating decimal a fraction. Whenever we make any decimal a fraction, we would always write it how we read it. Like if you saw the value of, like, let's say 0.9, you'd read that as 9/10. Okay, you'd write it how you read it. But when you have a repeating decimal, that's like saying, all right, I'm going to take like 2/10 and I'm going to say it's 0.22222, so on and so forth. So there is no place value that you can read for you to get your denominator. So there actually is a process that you take, okay? It's a 4-step process here. So you're going to see that we're going to do, you let your variable x equal the repeating decimal d. So write your equation as x equals d. So whatever your repeating decimal is. So we'll look at this first example and I'll walk it through. So x is equal to 0.4 repeating. So 4/10 repeating. Multiply each side of the equation by a power of 10 to form a new equation. As long as you do something to both sides of an equation, then you're keeping that equation balanced. You're just making it look different. N is the number of repeating digits. So in this first example, the number of repeating digits is just one digit repeating. So when we look at this here, we're going to say, all right, there's one repeating digit, so multiply each side by 10 to the first. Okay, so the new equation is going to be 10x equals 4.4 repeating. Okay, so simplify that. Step 3, subtract the original equation from your new equation. So literally take this original equation and subtract it. So minus x equals 0.4 repeating. Okay, so you subtract it and then you solve for x. So what you're going to see here is when you have 4.4 repeating and then you have 0.4 repeating, those 0.4s are going to cancel each other out. So you're literally left with just 4. And then 10x minus x gives you 9x. Divide both sides by 9 and you will get x equals 4/9. If you use your calculator and you say, okay, let me do 4 divided by 9, you're going to see that that equals 0.4 repeating. That process works. Okay, so take a look at the next one. You have negative 0.23 and the 3 is repeating. So here we only have one value that's repeating. That's that 3/10, or that 300, excuse me. So you write your equation, x equals negative 0.23 with the 3 repeating. There is one repeating digit, so multiply each side by 10. Okay, so just because it's only the 3 that repeats, we're going to multiply just by 10. The next line down says, okay, well, you got 10x equals negative 2.3 repeating. So it said subtract your original equation. So we're going to subtract this original equation. So we have minus, and then this quantity of x equals negative 0.23 with the 3 repeating. This looks a little funny. So when you are subtracting that quantity, what you have is you're going to have minus x, but then you're also going to subtract negative 0.2 and 3/100 repeating. So subtract that negative, that actually becomes a plus in this one. So I'm going to show you the work on the other side. So if you have a negative 2.3 repeating, and then you have a positive 0.2 and the 3 is repeating, you have a negative and a positive, so you're actually subtracting the 2. So when I was looking at this, I said, all right, well, I'm going to take 2.3, and then 10's repeating means it's going like this, so on and so forth. That's one way to write it. And then I'm going to have minus 0.2, and then that 3/10 is repeating again. So when I actually look at this and I subtract those two, well, my 3/10 minus 3/10 repeating, or I keep saying tenths, 3/100 repeating minus 3/100 repeating is gone. 3 minus 2 is 1. 2 minus 0 is 2. That's why we get this answer. And because the negative 2.3 repeating is the greater absolute value, that's a negative value here. That's how you're going to get negative 2.1. Okay? So you have 10x minus the x. That gives you that 9x. And then so 9x equals negative 2.1. Divide both sides by 9. And you're going to get negative, and when I did this one too, I was like, oh, let me convert this, because you can't have a decimal in your fraction. So I multiplied this by 10 and this by 10 in order to get negative 21 over 90. And then you can take that value and reduce to negative 7/30. It gets a little confusing. You really got to know how to use your fractions and work with fractions and work with those decimals. So let's look and see what happens when you have two digits repeating. You're actually going to go through that exact same process, but the only difference here was, instead of like in step 2 where you multiplied by 10, since you have two repeating digits, multiply by 100 and then go through the whole same process. So let's do this one together. Let's do number 1 together, Write your decimal as a fraction or mixed number. So here I I start off with that x equals negative 0.43 hundredths repeating. So step 1 said, all right, well, technically step 2, multiply by a power of 10 of however many digits are repeating. Since only one digit is repeating, we're going to multiply both sides by 10. So times 10 times 10. So that's going to give you 10x equals negative 4 and 3/10 repeating. Step 3 then says subtract that original, right here, this original equation. So minus x equals, so minus this quantity, negative 0.43 repeating. Okay, so when you do that, you're almost like distributing that negative. So when you subtract, this actually becomes a positive. And you're going to get 10x minus x gives me 9x equals, and then you have negative 4.3 repeating plus that 0.43. And I'm going to show you over here again. So that looks like this. So 4.33 repeating minus that 0.4 and then that 3/10 repeating. So when you actually subtract these, those are going to go away, and you're going to have 4.3 minus 0.4. So you're going to get that 9x equals negative 3.9. That's where that value comes from. It's from this over here. Okay, divide both sides by 9 because you got that one-step equation. X equals, and then I'm going to take that negative, this negative 3.9, and I'm going to times this by 10 and this by 10 to get them to look like integers. So it's going to be negative 39 over 90, which can reduce, because I want to divide both by 3, and it's going to be negative 13 over 30. Yes, weird. Completely understand. But just go through that step-by-step process. So try the next two and then see if you are correct. Okay, so in number 2, you should have gotten x equals 2 and 1/15. And then in number 3, you should have gotten x equals 3 over 11. So there is that 4-step process. You write your equation of x equals whatever that repeating decimal is that you're given. Step 2, multiply each side by that power of 10 of however many repeating digits. Simplify that. And then subtract your original equation and then solve for x.